We can now start working on our solvers. We have defined our export skeleton. We have reparented our controls. We have also removed the root bone. And now we can have this skeleton match the movement as defined by our pose node. The first thing we'll define is our center of gravity, which in most cases will be the hips. And I'll want this to follow both the movement and rotation of my center of gravity control. We'll set this using a rig attribute VOP. The skeleton will go into the first point, and the controls will go into the second. We can enter the rig attribute VOP, and we'll get a set point transform node so that we can set the transform. We'll need something to set the transform with, so we'll need a get point transform node. We'll start by getting the bone we are setting, so this will be from the first input, and we will set it using the joint's name. I can activate the name attribute to look at the names. At this point I have not done any renaming on my controls. If this was a rig for somebody else, I would probably go to the effort of renaming them. This could be done using a name node. It could also be done more procedurally using a vex script. However, in this case, I'll stick with the current names. I'll set the name field to be center of gravity. We can then duplicate this node. The duplicate will get the value from the second input. And this will be referring to the center of gravity from my controls. The set point control will be referencing the center of gravity as well, but in this case I won't set it directly. Instead I'll use the point output from my get point transform node. And I'll alter the transforms using the multiplication node, and in this case we'll multiply both sets of global transforms by each other. We'll then set the global transforms in the set point transforms node. The result of this is that we've essentially parented the rig to the center of gravity control. And manipulating the center of gravity control will basically confirm this. This is not the result we want, however. What we want is for the center of gravity for the skeleton to be at exactly the same position as the control. So instead of relying on multiplication to set the position, we'll set the rotation with the multiplication, and then we'll set the position manually. To do this, we'll get a matrix to vector 4 node. I'll set this using my destination matrix. We'll then want to get a vector 4 to matrix node. We can then connect the fourth of these vectors to set the position. If we connect this to our set point transform node, our rig will then move into position. However, the rotation will no longer be working. In this case, the rig will rotate to match a global identity rotation. So we'll want to get the rotation from our multiply, and we'll want to match it to the position. So I'll duplicate the matrix to vector 4 node, and I'll connect this to our multiply node. We can then set our transform using the first 3 vectors from this node, and now the spider skeleton should follow our controls correctly. I can then neaten the network up a bit. There are a lot of ways in which you can approach something like this, but this will be one of the simplest. So now I've got my hip control set up. While this is an IK control, it essentially works in an identical manner to an FK control. So I will not need any FK controls in this case. Instead, I'll start working on the legs, and I'll do that in the next video.